March 10th, 2015. You're looking at Earth-facing SDO images. This sunspot, guys, we've been watching continues to intensify and continues to throw out these strong M flares. That may not continue. We may see some X flares from this because as it turns around, it's right at the crossing point now of that magnetic connectivity point of Mars and Venus, where their IMF lines actually connect to the sun. And with that magnetic and gravitational alignment, will we see more energy? More than likely, because this thing seems to sense it. That purple V right in the middle is a coronal hole. In other words, there's no magnetic canopy over that part of the sun, and it's pouring that solar stream straight through. In other words, you don't have anything blocking it as far as magnetic canopies picking up that energy. It's just a coronal hole, and that's where you get a lot of solar streaming particles from. Again, Earth-facing images, this time different satellites, SOHO. I want to show you what was associated with those flares. Now, this is just a still image. This is at the end, the last frame this morning. I'll back this up and show you how we got to this point. But that is the fading remnants of a coronal mass ejection thrown out by that last flare we saw. We'll play this through. Notice your timestamp, March 7th. It started on the 6th. There goes the flares that have been, coronal mass ejections we've been seeing for the last few days. Coming up now on the 10th, just after midnight UTC time, right here. You see this? That's what we're dealing with. Now, you've seen 3 of these in the last 4 days come off that particular sunspot. But remember, as it turns towards us, they're going to become stronger and more geo-effective. You can see the A satellites are picking this thing up. And you can look at that 3 rapid-fire events that are just under the X flare line. That could change very soon because, again, if you remember the video, we are lining up with 2 planets right at that point where that sunspot is. I'm talking about you couldn't get any closer. But notice this particular CME tracker. If you've seen the videos from the last few days, they have been to the left. Now this one is going to side swipe the Earth a lot stronger than the other ones. Notice this. Notice to the chart in the far right. Right there. We're going to get impacts from these. Guys, the quakes are moderate. And it's like a quiet before the storm in between these CMEs. But that's going to change as soon as that impact comes in. And on the UTC time, it's at 0600 on the 11th. That means tomorrow night at midnight on the East Coast that's when that model predicts the beginning of the impact. But the models are just models. Depending on the speed that the coronal mass ejection left the solar surface will determine that. But we'll be watching it. Even the models say plus or minus 7 hours sometimes. But here you have a 10% chance of X flares, 40% chance of M flares, all from just the single sunspot. Now this one is a beta delta configurated spot. That's kind of unusual. You see the beta gammas or the beta gamma deltas, but the beta delta is what we're looking at right now, and it's lining up magnetically. That's important. I can't stress that enough as we see this go through. But let's take a quick look at the USGS map from today. Moderate quakes, 2 4.9s is always showing here as far as strong. That's it's called the Hugo Mayor's Office, Guam, 93 kilometers east-southeast. But very quiet. The quietest earthquake map we've seen in over a week or so. Usually you're into at least the 5s, 5.2s. There is pressure on the San Andreas Fault, guys. Of all the places right now, watch this area because, again, it's so quiet that the smallest pressures are showing up right there in that line. So just be aware that we've got that coronal mass ejection coming in somewhere around midnight tomorrow night East Coast time. So just be aware of what we're looking at, and this sunspot can throw out a strong flare between now and that time. And when the sunspot does that, guys, you have what I call the pulse flare effect. That immediate, within seconds, hitting the Earth. And you can see quakes at that point. Then you have the following coronal mass ejection, which is, when you say coronal mass, that's the surface of the sun, plasma. Very hot plasma, very thick in density. blowing off that surface. That travels slower than that pulse flare. So you usually have 2 events, sometimes 3, if the coronal mass ejection collapses back into the sun and causes a Hyder flare. Then you've got the pulse, then the Hyder flare, then the coronal mass ejection. And it's been, like I said, it's kind of like a quiet before the storm, guys. This is a heads up. We're going to watch it through the day. Keep your eyes open. All the links for both the solar activity and the earthquakes are on our website, bpearthwatch.com. Be safe.